Hi, hello again, and welcome, guys, to G Squared Academy, where excellence is epitomized. In today's video, we will be going through the June 2022 paper one for CSEC Chemistry. All right, so without further ado, let's get right to it. All right, so which of the following gases shows no reaction with moist litmus? So gases now may be acidic. Well, oxides may be of this nature, but gases generally tend to be acidic or neutral basic. You know, ammonia is a basic gas. We know that hydrogen is neutral and sulfur dioxide is acidic. Hydrogen sulfide is acidic to some extent. It is acidic, right? So hydrogen will not show any reaction with that because it is neutral in nature. Okay, so 38. A suitable drying agent for a laboratory preparation of ammonia is. Right. So when you're thinking of your drying agent, you're thinking of something that's not going to react with the gas that you're trying to make or interact with it in some way. And in this case, the best species to use is actually calcium oxide. It will not interact with the ammonia in any way. So, 39. Which of the following statements is true of carbon monoxide? It is an acidic gas. No, it's actually not acidic. It is very soluble in water. Hmm. It turns lime water milky. No. It reduces iron 2 oxide. Yes, it does. It can reduce iron 2 oxide. That is why it's used in the blast furnace. So, therefore, our answer here is actually D. So remember that iron may be reduced chemically, and carbon monoxide is that agent which does the reduction of that species. Okay. Oops. All right. So we go and head now. Mouse. 40. Which of the following metals is an important constituent of chlorophyll? Wow, magnesium. This is a memory thing. It's either you remember it or you don't remember it. Believe me, right? So magnesium is an important component of chlorophyll. So items 41 and 42 refer to the following table, which shows the reaction of four metals, W, X, Y, and Z, with the water or steam. The table also shows the products formed when the nitrates of each metal are heated. Okay, so let's see what happens down here now. W reacts with this species, and what we end up with here is no reaction with water or steam, so it's kind of unreactive, and it produces the nitrate and oxygen gas. X, as you can see, reacts with steam but not with cold water, which means it's more reactive than W, right? It produces oxide, nitrogen dioxide, and oxygen. Y reacts rapidly with cold water, and Z reacts slowly with cold water. So clearly, our most reactive is Y, then Z, then X, then W. Right? So Y, then Z, then X, then W. They may ask us that question. Let's see if they actually ask us. They say which of the metals is likely to form a soluble hydroxide. So which one is most reactive? So if you think about it, soluble hydroxides are things like sodium oxide. Sodium oxide is extremely soluble, right? Well, it's soluble. Okay, so and sodium is a highly reactive metal. So you're looking for the metal which is most reactive, and in this case, that is Y. All right. So that's how you're going to get that answer. Let's see question 42. In which of the following pairs of metals is the first metal most likely to displace the second metal from a solution? Just try to remember that a more reactive metal displaces a lesser reactive metal. So the most reactive metal here is actually Y. So Y will displace any other metal. Okay. So we know W is not going to displace X because X is not as reactive as W is not as reactive as X. So Y W is the least reactive, right? So Y can displace anything Z can displace X and W, and X can displace W, right? So which one is most likely to displace a second metal from solution? Will W displace X? No, W is least reactive. Will X displace Y? No, Y is the most reactive. Will Z displace Y? No, because Y is the most reactive. Will Z displace X? Yes. All right. And so our answer is actually D. So you have to constantly refer to the information so you can get the answer and look at the observations. All right. 43. Iron chloride, iron 2 chloride, and iron 3 chloride are two chlorides of iron. Which of the following statements about these two chlorides of iron are true? The percentage of iron by mass in the two chlorides is different. Okay. The colors of the aqueous solutions of the two chlorides are different. That's true. The aqueous solutions of the two chlorides do not conduct electricity. So that is not true because we know that aqueous solutions um, of ionic compounds, and you can question whether or not these are ionic compounds. That's debatable. Whether or not they're ionic compounds. But we're going to assume that they're ionic compounds in this context and that they will conduct electricity in aqueous solution. So statement 3 would be false. And let's see now, the percentage of iron by mass in the two chlorides is different, right? So how do you work out the percentage? You have to work out the molar mass of each of these species. So you have to work out the molar mass of that, you have to work out the molar mass of that, and then look at the mass of iron in the total mass. So it's 56 over the total mass here and 56 over the total mass here. And clearly you can see that there are more chlorines in that. So the percentage of iron in those two substances would be different, right? So our answers 1 and 2. All right. So we will push ahead. Okay. Okay. So we're gonna go on to our next question, right? 44. Which of the following processes produces a gas which is different from the other processes? So let's look at these things now. Respiration. All right, so respiration is where you have glucose, quote unquote, reacts with oxygen to produce carbon dioxide and water plus some energy. So CO2 is produced there. Photosynthesis in plants produces oxygen because it's the reverse of respiration. So carbon dioxide and water produces glucose plus oxygen. Heating calcium carbonate, if you heat this carbonate, you're going to get CO2. Oxidation of carbon monoxide, you're going to get CO2. So our answer is photosynthesis. Okay, so we go again to our next question, which is 45. Item 45 refers to the following equation. So what we have here is an alkene, and we're reacting that alkene with bromine to give X. What is the correct structural formula of X? So if you remember now, alkenes undergo addition reaction. So the bromine is basically going to be added across here like that. The double bond will break. Pay attention to that. The double bond breaks and you get the bromine added across the molecule like that. So the structure which best looks like that is this one here, D. So D is our answer. Okay. So next question, 46. Items 46 and 47 refers to the following types of reactions. Okay. Addition, isomerism, esterification, and polymerization. In answering items 46 and 47, each option may be used once, more than once, or not at all. What is the name of the catalyzed reaction which uses an alcohol and an organic acid? So if an alcohol and an acid are reacting, then we know that is actually esterification. So that is going to be C. It is, yeah, esterification. I was looking to see if condensation was there because it is condensation. The mechanism involves condensation, right? What is the name of the process by which proteins are formed from amino acids? And that is actually polymerization, which is D. Okay, and it's condensation polymerization in this case. All right, so 48, we're almost there. 48. Item 48 refers to two organic compounds, 1 and 2, of molecular formula C3H8O with the following structure. So here you have compound 1, then you have compound 2. And we can see that compound 1 is an alcohol from this functional group right here. And we can see that this is also an alcohol from that functional group. So we'd call these positional isomers since the position of the functional group changes, right? So we'll call them positional isomers because of that. So let's see now. Compounds 1 and 2 are known as isomers. There you go. Very simple and straightforward question. Isomers. Question 48. Which of the following compounds can decolorize potassium manganate 7? So, what can decolorize potassium permanganate? And of course, we know that potassium permanganate will react with alkenes, they will decolorize it. Okay, so 50, we go ahead. 50, here we go. Which of the following is a natural source of hydrocarbons? And of course, that's petroleum, is a natural source of hydrocarbons. 51. Which of the following substance is soluble in water? So now you're looking at an organic species and you're thinking, which of these is soluble in water? Well, you have to look for something which will interact with water, like dissolves like dissolves like. And so we're looking for something which may have a positive end and a negative end. So something slightly polar. And the best answer here is going to be the alcohol. The alcohol has this thing right here, the OH group, which confers some polarity to the molecule. This is an ester. So esters are usually not polar. So that's not going to work. And definitely not these two in the middle. Right. And as I said that, pay attention to the fact that two of your answers are going to be completely outlandish. Okay, and then the next two are pretty close. 52. Hexane is an alkane with 6 carbon atoms per molecule. Which of the following is the formula of hexane? So you're now looking at an alkane, and the general formula of alkanes is CnH2n plus 2. So since hexane has 6 carbons, you're going to replace the N with 6. So this is going to become C6, and then H 2 times 6 is 12 plus 2, so that is 14. C6H14. So your answer there is B. 53. We scroll down a little bit. Which of the following tests can be used to distinguish between an alkane and an alkene? So burning, yes, burning can be used because alkanes burn with a blue flame. Alkenes burn with a less blue flame, and it's kind of yellow, it's kind of sooty, meaning that it's orangish in nature, and it produces that black um, carbon, right? Conductivity, no. None of these things conduct in any case. So you can't use conductivity measurements to test for the difference. All right. Adding bromine solution. Yes, if you add bromine solution. So let's say you have both solutions or both substances, and you add bromine to them in the dark. Bromine would only react with the alkene, right? Because for the reaction with the alkane, you need light. So your answer here is going to be 1 and 3. 1 and 3, which is D. Okay. So we go on again. 54 item 54 refers to the following compound, which we can see is an alcohol by that functional group. Which of the following phrases correctly describes the compound shown? It's an alkane. No, it's an alcohol. And we just said that it's an alcohol. Notice this, don't lose that. Make sure you look at the molecule carefully, right? Some students may miss that OH group right there and say alkane, unfortunately. So it is an alcohol, right? 55. Which of the following substances is not a polymer? So let's see now. Polymer, that's fructose. Fructose is not a polymer. And some of these things you're using your vast knowledge of other scientific subjects to get the answer. Nylon is a polymer, proteins are polymers, and cellulose, of course, is a polymer of glucose, but fructose is not. Okay, so We gone. 56. We're almost there, guys. Almost there. Hang in there. A polyamide is formed by a condensation reaction between a molecule containing a polyamide, such as a protein or nylon. See, just up there, they're going to ask you about it down here now. These contain, their functional group contains NH2 initially, and an acid for you to get the amide link, which is C double bond O N H, generally speaking. So that's your amide link. So it contains at least one COOH group with another containing at least that. So your answer here is A. All right, good. We're doing well. 57. 57. Which of the following substances is a product of a halogenation reaction with methane? So if I were to halogenate, if that's even a word, methane, it must be done in light, and then these are products that we can get. Which of the following is a product? So actually, when you do this reaction, and I'm kind of just going to draw a little bit for you here. So your methane reacts with, let's just say, chlorine, right? What happens is that it's an addition reaction. So it's not an addition reaction, it's a substitution reaction. So one of the hydrogens will be replaced by a chlorine. Okay, so what you're going to end up with is CH3 Cl, and the hydrogen which was lost is going to combine with the other chlorine to give you HCl, which is hydrogen chloride. So your answer there is hydrogen chloride, and I'm just going to clear up that up here so you can see all of that. So hydrogen chloride right there is your answer. Okay, 58. And let me erase this as well so we can actually see the question. 58. So which of the following substances, right, can be produced directly from ethanol? What can I make directly from ethanol? And so you're looking now at the reactions of alcohols, right? And here you have ethene, which you can, yes, because ethene can be formed from the dehydration of ethanol. Can we get ethane directly? No. And can we get ethyl ethanoate? Yes, we can. If we react, ethanol with ethanoic acid, we'll get ethyl ethanoate. So our answer here is actually 1 and 3, which is B. All right, so we're doing well. 59. Items 59 and 60 refer to the following compounds. C2H4, which is an alkene, C2H6, which is an alkane, C3CH3, CH2COH, which is actually an acid, and then you have an alcohol below that. In answering items 59 and 60, each option may be used once, more than once, or not at all. Which compound is an alcohol? Well, that's pretty straightforward. D is an alcohol. So that's D. Which compound is an alkene? That's also pretty straightforward, and that's A. Now you have to remember the general formula of these things. Alcohol CnH2n plus 1OH, and for your alkene it's CnH2n. So all you need to do is to check if these things fit into these categories is just look at the formula. So let's look at the alkene, for example, right? You have two carbons, so N is 2, and then now you have 4 hydrogens. 2 times 2 is 4. So it definitely fits that what do you call it now, that general formula. And you do the same thing for the alcohol. So you count the number of carbons, and this right here, let me just point out that this thing right here where you have the CH2 bracket 2, what that is basically this. You have that, right? And that's hydrogen, that's hydrogen, that's hydrogen, that's hydrogen. Okay, but they didn't want to write it twice, so they just write CH2 and multiply it by 2. That's all. And it's the same thing for the other one below that. All right, so there you have it, guys. This is June CSEC Chemistry 2022, paper 1. I wish you guys all the best in your exam. I am Gilly Gills, and this is G Squared Academy. See you next time.